Hello everyone, today we are going to continue on the topic of serializability, and in particular, we'll identify one type of it, which is conflict serializability. The notion of conflict serializability is pretty simple. If you have a schedule that is conflict serializable, you can avoid conflicts and meanwhile tweak your schedule to a serial order. So we'll see how to do that in a minute. Let's get started with an example. Here we have a scheduler planning for 3 transactions. But if we show the schedule directly to, let's say, a high-level user, they will probably reject this idea and say, you cannot do this. All transactions must be atomic. Right? You cannot have a task executed in the middle of another transaction, right? So what we have to do is to prove to them that our schedule actually behaves the same as a serial one. In order to do that, we transform this table into a sequence where the subscript is the transaction number. Next, we want to try to swap adjacent tasks until there is no interleavings. That is, we want all the tasks of each color to be grouped together. But while doing that, we need to keep in mind 2 things. We need to avoid 2 types of conflicts. The first one is the write-write conflict. We cannot swap 2 tasks if they are writing to the same position in the memory, because it will alter the states during and after the transactions. And secondly, we want to avoid the read-write conflict. That is, for instance, if we put this reading from A in front of a writing to A, you would result in a dirty read that the value read is inconsistent. As long as you do not cause these 2 types of conflicts, you can swap however you like. Let's start with transaction 1. We want to bring these 2 tasks together, but we realize that we cannot move W1A to the right because there is a write-write conflict. So let's try this pair. They are looking at different places, A and B, so it's totally fine to swap them. And for the same reason, we can swap W2A and R1B. And it looks better. We probably want to swap R3A and R2A. They are both looking at A, but there are 2 reads, meaning that there is no conflicts. And we end up with a serial sequence, which proves that the original schedule is conflict serializable. So good so far? Okay, and let's try another one. Everything is basically the same, but we have a reading from A instead of a reading from B. So can we perform the same swappings here? Let's see, we still cannot swap W1A and W2A because of the write-write conflict, so we need to start with this pair again. And also, if they are looking at the same place, 2 reads do not cause a conflict, so it's fine to swap them. But now we end up with a W2A and a R1A, and we realize that if we swap them, it will cause a read-write conflict. And no matter how you try, you cannot get this W2A out of the middle of transaction 1, which means that the original schedule is not conflict serializable. But to rigorously prove that, you would need a precedence graph, but that will be covered in the next part of this section. Thanks for watching.